Hello and welcome to today's talk. I'm Carolyn Woods from InEight, and I am joined today not by Dan Patterson, who has actually been called for some travel this week, but instead we have Paul Self, who is the Executive Vice President of Project Planning, presenting today a better crystal ball for planners and schedulers. Paul, I'm really eager to hear more about your crystal ball. You are the co-founder of Basis, and Basis was a company that was acquired by InEight in 2018. I know a little bit about your experience implementing project management solutions and doing some consulting for a lot of Fortune 500 companies. So I know that you've got experience that crosses a lot of industries, including aerospace and defense and government, and even energy. So I'm really glad you were able to step in today and make today's presentation. To the audience, I'd like to say that if you have questions, you can go ahead and type those into the question window, and then Paul will take those, because we expect to fill a lot of today's time. Paul will take those and address those with you in email directly. So you're welcome to chime in at any point and type in a question into the question window, and then I will save those during the presentation for Paul afterwards. So faking his very best British accent by standing in for Dan Patterson today, Paul, I'd like to turn it over to you.
Well, thanks very much, Carolyn, and I genuinely appreciate getting the chance to be a substitute speaker, and I will not burden everyone's ears with my horrible fake British accent. So
thanks so much.
Yeah, so we've got a lot to cover today, but before we jump in, I wanted to introduce Keith Anderson as well, who's our Director of Customer Success here. And Keith is not only a subject matter expert in the topic that we're going to talk about today, our proactive risk prediction strategies that we're suggesting we employ, but he also helps our clients make sure that they successfully implement, take advantage of, utilize our InEight solutions inclusive of Basis. So Keith, thanks for
thank you. Thanks for having me here. Great to be part of it.
I'm excited that you're here with me. So with that, we're going to jump right in, because we've got, as Carolyn said, quite a bit to talk through. One of the things we tend to start each one of our conversations with kind of a fundamental belief statement, and and our belief is it's our approach to planning and the resultant overly optimistic plans that lead us to perceived project failure. So today we wanted to discuss some suggestions on how we can leverage technology to address that fundamental issue when identifying and incorporating risk into our projects. And in order to do that, we wanted to look at how we accommodate for our historical experiences when planning our projects, and combine that with how we capture the expertise of our team. Those things are inputs into the very early stages of a risk process, and maybe a little bit different than the way organizations think about risk today.
Yeah, and I think it's more about confidence, right? So we call it risk, but it's also confidence, and there's a bias in all people, and you ask one person and they're might give you an answer that's based on their last project, and it might be really good, and the next person is going to have a really bad experience and is going to sway the other way. So
so really what we're going to talk about how we capture, incorporate, and understand the impact of project risk, and determine how that changes our confidence in the plan. So that was a great
right on.
Thanks. So hopefully this is educational and a little bit fun as well as we go along. So the brilliance of critical path method. So CPM has been a staple in the project management space for over 60 years, and it often gets a bad rap, which is unfortunate. The basic premise behind CPM is that we feed the CPM tool activities with duration and logic, and the algorithm does the work for us. It calculates the dates and the float, and it's a pretty straightforward process. It's been the backbone for all capital projects for a very, very long time. Yet after all these years of utilizing this critical path method for project management, projects continue to be late. But I don't think that's necessarily the algorithm's fault.
It's not. That's a technical thing, right? It's the project planning that goes along with it.
That's exactly right. It's a great lead-in. Thank you. So with that, we think it's because a schedule is only as good as the inputs we feed it. As you said, it's no different than Keith, if you're about to go run a race, right? And you ate a hamburger and had a beer before you started your race.
Probably wouldn't go
you wouldn't perform that well, right?
No.
So we tend to get pushed into building the best case version of our plans. And that means from the onset, we have a very limited opportunity to succeed. We leave no room for things like external events or uncertainty for items like quantities and install rates. And we start our planning process and our plan with something that's overly optimistic and overly aggressive. Yeah? Okay. So let's talk a little bit about risk analysis as well. When we talk about schedule risk analysis, most people immediately think about Monte Carlo. And so as a bit of a primer on it, Monte Carlo simulations allow us to predict a potential range of outcomes. I'm sure we have lots of folks on the line today that have probably some deep expertise with risk analysis, but it's intended to help us account for the unknown by allowing us to capture two primary inputs, right? We want the uncertainty associated with the activities and scope within our plan. So how confident are you in that, like you said earlier, Keith? And the identification of discrete risk events, things that may materially, say that 3 times fast, materially impact our plan. So we combine these inputs with the simulation, and this gives us p-values, our probability values. And it allows us to account for that uncertainty and risk event impact. So ultimately, I think a risk-adjusted plan reflects reality better than your deterministic CPM schedule. And we'll walk through a little example here on the screen. So we've got our deterministic CPM plan at the top of our screen, task A and task B taking place in sequence for a total of 10 days in duration. We've got task C taking place in parallel. It's 8 days, so we've got about a couple of days afloat associated with that task. But when we start to account for things like uncertainty and risk events, that critical path can change on us. And it allows us to focus in the correct area of the plan and where we need to proactively address risk on our project. So when we look at our risk-adjusted example, we now have task A and task B still taking place within sequence, a couple of days worth of risk-related uncertainty tied to them, and 5 days of risk event impact tied to them as well. So we've got a total of 17 days there. But likewise on task C, now it has 6 days of uncertainty and 6 days of risk based upon the inputs to the model that we've created. So ultimately, it's become the critical path.
Yeah, we keep on stacking into it.
Mm-hmm. So the 3 fundamental issues with Monte Carlo. So and thinking about simulation. So looking at a given p-value is really incorrect. Each iteration is actually its own deterministic schedule. So the statistics oftentimes get misinterpreted and misused. For example, so in another way, a low confidence of hitting the deterministic date does not always necessarily reflect a risky schedule. So Keith, many of the risk workshops that we've done where we've worked with organizations to identify the risk events, categorize the uncertainty for scope areas within the schedule, they've resulted in where the deterministic schedule itself has a P0, but that's not necessarily a reflection of the risk on the project. It's oftentimes simply an indication of an overly aggressive original plan.
Yeah, I think people think about the risks as they're putting together the deterministic durations at times, right?
Mm-hmm.
And we want to take that out of that part of the original durations of the plan, of the task activities. And I think number 3 here is the most, the biggest flaw or fundamental issue of Monte Carlo is that not a lot of people understand it. I mean, there's really good people out there that know how to run the simulation and what the inputs and outputs are going to provide, but you're your everyday project manager or business manager doesn't really get it, and there's got to be a simpler, more straightforward way to show people the risk-adjusted schedule.
And in our experience as well, I mean, it seems that, it too often borders on an academic exercise,
Yes.
right? And not something that's truly supporting how we make decisions on our projects. So that really led us to one of the reasons we created Basis, and focusing on finding a better way to accommodate for risk when building a plan by taking advantage of our historical lessons learned, by accounting for our team member opinion on the feasibility of the plan, their confidence in the plan, by providing a simplified means of capturing and incorporating risk into our plan, but during the planning process, not as a separate exercise. And we really do this in three ways. We talk about it in the context of AI, or augmented or artificial intelligence, HI, which is human intelligence, and RI, which is risk intelligence. So AI lets us allow, if we implement it correctly, AI will do some of the work for us and make building the plan and analyzing the plan easier for the planner. And ultimately, it results in us having a lower risk plan from the onset of our schedule. Human intelligence, I think, the input from the team is probably the most valuable asset in an organization. I mean, I think their expertise is really where we've lacked identifying really good information during the initial planning process. So let's make sure that expertise is accounted for, right? And then finally, risk intelligence. I mean, risk is a critical component, but it's too often conducted as a separate kind of independent exercise. So let's embed capturing and analyzing risk into the plan creation process. Again, not as a secondary action. So as we go through the rest of today's presentation, we're going to tackle each one of these kind of in sequence. So let's jump into to the AI bit a little bit more. You like that, don't you?
I like the AI.
The AI bit. So there are, when we think about Basis as an artificial intelligence or augmented intelligence solution, really any AI system, right? There are multiple categorizations of AI systems, and Basis is known as an expert system. So what that means is it provides suggestions based upon information stored in a knowledge library. So if we move from left to right on our screen here, we're applying AI concepts to the science of CPM scheduling. So the knowledge library needs to take into consideration and store relevant CPM data and ancillary data related to the schedule as well. So imagine the knowledge library being a home for your as-built CPM schedules, your schedule templates, your risk events, things like productivity rates, and additional items that allow us to give context to the data within the knowledge library. In the middle sits the inference engine and the neural net. This is essentially the brain inside of an AI system. So the inference engine understands the data in the knowledge library and uses a set of rules and criteria to make informed suggestions to our end user, the planner. And as the planner, I have the ability to leverage these suggestions to benchmark existing plans, to build a new plan from this valuable history, should I wanted to take it a step further, without having to go and farm all of that data myself. It's presented to me during the planning process. So, and I can also start to incorporate commonly occurring risk events, and doing so much earlier in the project lifecycle. So as the planner uses Basis, we also have this machine learning element that spans the entirety of the solution that kicks in and calibrates the suggestions made based upon the behavior of the user, meaning what the types of suggestions it makes. If the user accepts that suggestion, it will make more suggestions like that. If they don't, it will recalibrate and come up with better suggestions the next go round.
Yeah, and I think it's important to know or recognize that it's the AI, the augmented intelligence. I think it's very important that we term it that way, right? Mm-hmm. Augmented. It's not a machine automatically creating a schedule, creating the plan. It's very much a augmented solution that's helping you to do that, right? Like if you open up Google Maps or Waze or whatever your favorite, it's suggesting different routes that you can take. Ultimately, at the end of the day, you're gonna take the route that you think is best for you, and so the augmented intelligence is helping you make the right decision, not just automatically doing it for you.
So let's go through a little bit of a primer and on augmented intelligence and how Basis makes these types of suggestions, and then tie that into the risk process itself. So Keith, I know how much you like cheese. Would you like to go to a cheese festival with me?
If there's wine involved or beer, then yes, I'm all in.
Okay, so let's come back to that because we may have to influence our criteria here for making that suggestion.
Sounds good.
So we wanted to shed a little more light on how Basis or any AI expert system goes about making these types of suggestions. So if we simplify it, and in this example, we have 3 binary variables, right? And these are our criteria to make our decision on going to this fantastic cheese festival, Keith. We want to know, 1, is the weather going to be good? 2, I have to make sure you actually want to go with me. You may not after this webinar. And 3, we want to know if the location is close. So each of those variables also carries a weighting because some criteria may be more important than others. So weather is very important for our decision, so it carries the highest weighting of our criteria. And then finally, we have a threshold. So essentially, we have a minimum score that determines if we're going to go or not. And there is no in between. It's a binary variable. It's a binary value. So if we score higher than the threshold, then the cheese festival is a go. So a couple of examples. So in our simple example, we've determined that the weather is good on the left-hand side. And so even if you don't want to go and the location is not nearby, we're going to decide to go. And that may not be correct, right? So alternatively, let's say you do want to go. It is nearby, in our example on the right, but we expect bad weather. So we're not going to attend the cheese festival and we'll have to wait. So if our output or the suggestion doesn't feel right, then the neural net gets retrained with different weightings. So I may need to weight more heavily the fact that you do or don't want to attend in order for us to come out with the appropriate suggestion. Make sense?
Yes.
All right, let's start to apply it to a CPM schedule example. So and this objective, we want Basis to come back with a suggested duration based upon our historical performance. And in this example, we're going to say our variables are, does the description match? Is the task coming from a similar phase in the project? And is there similar logic? You know, is it taking place within the same phase, and is it logically tied in a similar way to the data elements within the knowledge library? And then we'll apply our importance weighting. So the purpose of this neural net inside of Basis is to prioritize the suggestions the computer makes to the planner and the team. So in our next simple example, if the description matches, but our phasing doesn't, and our logic is different, we don't meet our threshold. So it's a poor suggestion and we don't make the suggestion, right? If the logic and phasing are similar, we have a strong enough score to categorize this as a valid suggestion, even if the description isn't necessarily a good match. So this gives us a suggestion, and this is the criteria that Basis leverages to provide that suggestion back to the team. So the knowledge library itself, we have some building blocks, right? We've got the knowledge library, we've got the inference engine, and we have the outputs that it provides. And we talked earlier about expert systems and the importance of the knowledge library. In the context of CPM, we need some standard data sets to draw our suggestions from. We call this loosely structured data, and it includes things like historical as-built, risk events, productivity rates, but we also know every project has a story. And one of the obstacles we've had to overcome when implementing Basis, and you have experience with this as well, Keith, is every project has a story. So if my project had a weather-related delay, and we want that suggestion to take into consideration that delay, we don't want the suggestion, sorry, to take into that consideration that delay, then we need a way to normalize that suggestion back to the end user so that the next time we build our project plan, we don't automatically incorporate a 30-day weather delay.
Right. It's a way to provide context to the plan in our knowledge library and or the plan that we're building. And as part of that context is to be able to normalize based on things that may happen.
Sure. So like, was it a poor performing project? Was there an area in the schedule that experienced an anomaly during execution? Was the work performed in a location where permitting traditionally takes more time? That context, as you said, is used to make better calibrated suggestions to the planner. So the inference engine makes these suggestions to the planner on items like duration, project phasing, and risk events. Make sure that we're considering the appropriate elements when building our plan. Those suggestions are then ranked based upon the degree of match or confidence that basis has, and if that suggestion is right. And that's what we're seeing on the right-hand side. Just like you mentioned Google earlier, just like you would do a Google search, you enter in your search term, and the highest ranking best suggestions get returned first. And that's the same is true within basis.
And one of the questions I commonly get for new customers is, how could I take a number of these suggestions and aggregate them or use the average? And Basis also provides the means to do that. We can take multiple suggestions and bring them together, to bring all those suggestions together as a way to use those multiple. So you can use the templates and multiple past projects to all come together to provide your current project network and durations.
Absolutely. So let's tie this back to our risk process a little bit. So first, we'll walk through really briefly how we're going to benchmark our plan against our history. And the reason we do this is because it helps us avoid creating an overly optimistic plan at the onset of our scheduling process, right? Our plan development process. And then second, we can actually use these benchmarks to address those areas of concern where I may not be in line with how I've historically performed and executed my projects. So the difference here is that benchmarking is often viewed as a static kind of reporting exercise, but within Basis, we have the ability to react and take action on it. And then finally, identifying our risk events and tying them to our projects, we can do it much easier, and we can create that mapping between those material risk events and the elements within the schedule that they'll impact in a way that's far faster than could historically be done with traditional risk process.
I think another way is our phasing capability, and I'm sure we're going to see that in the demo. We see it here in this screenshot is the ability for Basis to tell you that, for example, permitting might start within the first 5% of a project, and are you within that phase window for that section? So you're taking out risk if you're seeing that this section is going too far into the project, then you can reduce the risk by bringing it back in some means.
Sure. So let's take a look at how AI can be leveraged during the plan development process to help improve and reduce the risk on our first time developed schedule. So I'm going to do something a little bit different today. I'm actually going to pull in a existing schedule, and we're just pulling in a Primavera XCR, and we'll give this, Keith, you have a good project name?
Each Thursday.
Keith's Cheese Festival Project.
All right, while Paul's doing this, I'll mention that Basis is 100% web-based, browser-based. Use your favorite browser, Google Chrome, Firefox. We're on a Mac, so we're using Safari on a Mac. Super simple to get to for users, and they're typically often running with a minor training guidelines.
Thank you. So we imported a really simple schedule here, and I can immediately start to see if I click on elements within my schedule, Basis is already, its AI engine has already kicked in and it started returning suggestions. So we can see on the right-hand side, we've clicked on our pre-construction related scope, and it's coming back with some pre-construction related suggestions, a a construction suggestion, these are elements that we could benchmark against, or we could even adopt subnets, activity sequences from these items in the planning process. But we're going to do something a little bit magic today, and we'll use our magic wand here, and we're going to allow Basis to go in and take the best suggestions that it can find from the knowledge library and automatically benchmark the elements within my plan against those best suggestions. So
that is magical.
That's why it's a magic wand. So one of the things that we see right off the bat after pulling this plan in and adopting the benchmark suggestions automatically from the knowledge library is we can start to see not only where we're in, let's change our annotation here real quick, not only where we're in or out of alignment from a duration perspective. So for example, on our design related scope under our pre-construction summary, this design related scope in this current project is 42 days longer, right, than what we would traditionally see based upon the suggestions that came back from the knowledge library. But also, if we click down to, let's click down to our procurement related scope and blow out some of this information. We can see here for procurement, or we go to our submittals and approvals, that we've got a significant delay in terms of phase. So from a duration perspective on our submittals and approvals, we're only a couple of days longer than what we see from the data within the knowledge library. But we're taking place, this activity is actually taking place a little bit later than maybe it should, again, based upon our history in the knowledge library. So this creates an early stage checkpoint in our risk process, and it's outside what we would traditionally consider as part of the risk management process. But now we can determine how aligned we are with our comparative projects, our history, our templates, and any other data that's resident in the knowledge library. But we can also take it a step further. We can actually adjust our plan to reflect this history and use the benchmarks as the basis of our plan. So for example, if we're on our procurement related activity here, we can see that it looks like for some of these elements, we've under-egged procurement a little bit. We're 102 days shorter than we should be based upon our historical experiences. So rather than having to go in and manually adjust specific activities, we can actually leverage Basis to factor to that specific suggestion. So if I say, you know what, I want to match my duration benchmark, I can factor those elements, and Basis will do the best it can based upon the calendars that are assigned, working and non-working time, to get us to as close to that 317-day duration as it can. And it automatically adjusts the activities that sit beneath it based upon that factoring. So in addition, we could have pulled subnets or activity sequences to further refine our plan, allowing us to not have to search through all of our archive schedules or do manual comparisons to our archive schedules. But the AI engine not only supports us in providing kind of this early phase analysis, but it also helps us during the risk identification process. And we can see that the suggestions coming back on the right-hand side, we've got some risk events tied to elements within the knowledge library that could be relevant to our project. So let's jump to our design related scope. And let's take a look at some of our project register items, and let's add a risk event. And I can see I can create a risk event from scratch, and Basis will guide us through that definition process, right? It'll tell us, hey, you need to define the event, what is the cause, and what's the impact of that event. But we can also start to take advantage of the AI engine and the suggestions it brings back from the knowledge library. And it's bringing back design scope related risk events at this point.
Yeah, so, this is really great. So during the project creation, Basis will help to identify the risks, not later in a separate risk workshop, right, as I'm creating the project.
Right, I can do it really early in the project life cycle. So we'll accept our this risk to the risk of design delays due to poor scope definition. Maybe we need to rescore this risk. Maybe on this project it has a higher probability of occurring, but the scope definition, we think we're going to be able to get through it, so it may have a lower impact if that were going to occur. And we can even give it a cost impact and say this is, this will have a $10,000 impact on our design related scope if this risk event were to actually occur. So we've now tied this risk event to our design scope, and when we go through the review process and basis in real time, we're going to be able to assess the impact of this event on our plan. So imagine we've walked through our schedule and used the analysis that basis provides in comparison to our history, our templates, and we've identified relevant risk events as part of that process. Now we have the opportunity to get feedback from our extended team. This is leading us into the human intelligence piece of our presentation today. These individuals that we want to seek feedback from are typically not CPM planners and schedulers. So there may be our superintendents, they may be discipline leads. They're the ones closest to the work that will be performed on this project. So we can look at our design related scope or go all the way up to pre-construction, for example, and we can assign individuals to come and provide us feedback on the schedule. So Keith, I'll ask you to give us some feedback. I'll assign myself as well. And maybe since Dan decided not to join us today, we'll assign Dan and ask him to provide us some feedback as well on the plan. So,
but this is great. Dan's halfway around the world. He can still provide us with this input, and we don't have to all get together in a room. Or when we do get together in the room, it'll be that much more valuable because he's been able to see and evaluate
the plan,
the parts of the plan that we've asked everybody to review.
That's exactly right. So what happens was once we make those assignments, these individuals get an email, and it takes them, provides them with a link, and then they can immediately log in and start to provide their feedback on the plan. And this leads us to, we'll jump back to our projects here real quick, but this leads us to how we accommodate for human intelligence, the HI bit, when going through the planning process and the risk analysis and risk identification process. So we said earlier that human intelligence is probably the most valuable asset that an organization has to offer, and it's oftentimes ignored until it's too late, right? We've already snapped our baseline, we've started project execution, and the team gets a list of what's supposed to be happening, and we're already having schedule delays. So the key here in capturing this team's feedback, because they're not necessarily CPM planners and schedulers, is to provide them with a very simple scorecard whereby they can tell us if the durations are accurate, if we've gotten the sequence right, and even if we've identified the appropriate risk events. And what's really unique about this process is they are operating in their own unique sandbox of the plan. So they can make any changes they would like through this simple scorecarding process and not impact the underlying integrity of the schedule. The planner still has complete control over what actually makes it into the plan. And even further, I can have multiple people contributing to the same area of the plan, just like we did. We asked Dan to contribute their feedback for design, as well as yourself and me as well.
Yeah, and on a major project, likely that there's going to be a schedule review, and this is oftentimes the preliminary to the schedule review, where people have the opportunity to see the plan before they all walk into the room together, make their contributions, identify risks, issues, other registers, suggested schedule changes, and it's all captured electronically. I was at a schedule review a couple of weeks ago, Paul, and it was going from level 2 to level 3.
Mm-hmm.
They were talking about the electrical portion of the schedule, and somebody said, I feel like we went through all this last time, and where are the notes from the last review session? And I just thought, man, if using basis to have done this, we would have captured all of that and could have contributed into that schedule review and made it that much more of a valuable situation.
Right. So what we're really looking for, you know, on the human intelligence side, is getting validation through that process, right? And when we relate it back to risk, teams don't care about Monte Carlo analysis or distributions. But what happens as I'm capturing that team member opinion, that feedback reflects the uncertainty or the confidence the team has in the plan. And really, if you were going to run a Monte Carlo simulation, it can be used as the basis for those 3-point estimates that would be used during the Monte Carlo simulation. So it feeds the risk model, and those differing opinions define the ranges of those 3-point estimates. So in reality, it's no longer based on what's oftentimes an arbitrary value or a generic plus or minus 10%. We have real ranges based upon the feedback from the team that's actually going to be responsible for executing the work. So if we take it a step further, wouldn't it be fantastic if the team could also take advantage of the AI engine and identify risk events during their feedback process as well?
Yeah. And this is honestly, this is the most excitement that we get about Basis and related to the markup is the ability and opportunity to identify risks all together with the schedule review. So not as a separate event or a separate workshop, but to be able to do all that from the start.
From the start. That way, when you do sit down in an interactive planning session or a workshop, you have the feedback from the team available to you.
Exactly.
So we've captured our team's confidence in the plan, and they've had the opportunity to identify material events that could impact the schedule. So let's jump back into Basis for just a second and show how we might address this. So we're not going to use your Cheese Festival project. We're going to hop into one of our vertical build projects, and I've assigned myself as an individual that's going to perform markup. And I've got 9 items that I need to provide feedback on. And again, I'm operating in my own unique instance of the plan, right? I'm not impacting the underlying integrity of the original schedule. So using the scorecard, I can quickly say, you know what, I'm okay overall with all of these durations. But, you know, for example, early stage construction, I actually think we can get that done a little bit faster. So I'll take 10% less time to do that work. Or as well, my permitting documents, I know we always have issues establishing those permitting documents. So it'll take about 25% more time. And in real time, I can start to see the impact of my feedback on this plan. I can see that I've added about 12 days in duration to this activity, which is resulting in a 16-day delay because of the calendars that are assigned and looking at things like working and non-working time. So,
and we can see the knock-on effect on the next task to create early stage construction.
That's exactly right. And we can display the logic here and we can see why that knock-on effect is actually taking place. So ultimately, I may have delayed my project significantly by simply changing the duration on a single activity. So, but we'll take it a step further, and we can start to identify risk events as part of this process as well. So if let's identify a risk event associated with my establishing permitting documents. We've already got one identified in our basis layer of the project for changing requirements from the owner, right? We can say, hey, we'll have a very simple risk event that we'll incorporate that's just a simple risk of permitting delays, right? And as the team member, I can also provide suggested probability and impact scores as well. I can say, hey, this is likely to have it's a low probability of occurrence, but if it does, they typically impact us by about 60 days. And now I've captured from the team their feedback on whether or not I got the durations right? Do I need to add time or take away time? And if I've identified the correct risk events as part of this process. And should they want to identify additional information as well, they simply can add a new risk event, they can add a risk view, they can request a schedule change, and you can capture more intelligence and justification as part of this process as well. So anything to add, Keith, on how we perform the markup process?
Well, I think what we're looking at here is a very limited view of the schedule, and this is great for those discipline leads, that or a subcontractor. If desired, we can also let people look at the full picture,
Right.
and see their piece of the schedule embedded into the full project plan, and see how they would potentially impact the whole project plan.
So not just their area of the schedule.
Not just their area,
and they can
right?
edit,
they can see the whole thing,
they
but
can
only edit their
area,
their portion.
So that's a great point. So now let's jump into kind of the risk intelligence piece of it and how we start to take advantage of each one of these varying pieces of input that could have an impact on what ultimately I incorporate as the durations into my project schedule. So what we've gone through so far is we leveraged augmented intelligence to help us calibrate our plan. We brought in an existing plan. We benchmark it against the information within the knowledge library. We took action based upon those benchmarks and hopefully resulted in a more calibrated plan, right? A better plan based upon our historical performance. And then we assigned the team, and the team went in and said, you know what, in our simple survey and my own sandbox, this is what I think the plan should actually look like. And we can assess that they can assess their real-time impact during that process. And now we're to the point where we want to consolidate and adjust our plan based upon the feedback from the team, and adjust it from a risk perspective as well. Take into consideration the events that have been identified and the uncertainty of the team as part of that process. So we set uncertainty range, like traditionally uncertainty ranges get derived based upon an arbitrary plus or minus 10%, or someone that's not necessarily associated with the scope for the project, trying to determine what the uncertainty is on a given set of tasks or activities. Now it's based upon real feedback from the team. Risk events get defined in the context of the actual schedule. It's not done as a separate exercise. This also means the mapping of events, which is a very difficult thing to do in risk workshops, determining, I've identified a risk event, what areas of the schedule is it actually going to impact? That's done because you're identifying those risk events in the context of the schedule itself. And then in real time, I can start to assess the impact of both that uncertainty and the team's identified risk events. And we're going to show you how to use a basic algorithm instead of having to run 10,000 iterations of a schedule through a Monte Carlo simulation engine, so that you can see it in real time and use it as a better kind of decision support tool during that process. And then I can choose to embed all of this feedback into my basis layer of the plan. I can use it as the basis of my baseline, so I start my planning process with a much more achievable, less aggressive schedule. And then one thing to note, so we've incorporated as part of this process an enterprise risk register, right? So it's home for all of these risk events within Basis, and Basis will draw from these risk events when making its suggestions. So the concept of this knowledge repository is really important because it allows us to build on our collective data set every time we build a plan. So if we add a risk, that becomes part of our knowledge library. And the next time I build a schedule or a plan, it's there and available to me. So every project has the opportunity to take advantage of our prior projects' experiences. And not only that, the AI engine itself gets smarter and our data gets deeper, and we have plans that better reflect reality.
And these risks that are part of the enterprise register are either part of the enterprise register or also attached to knowledge library projects, templates, and past projects.
Correct.
To leverage the knowledge of those projects.
Right. So let's kind of bring all of this together. Let's jump into our review cycle and let's see what the knock-on effect will look like with the impact of risk. Let's see what our team's feedback has done to our plan, and then let's decide what's actually going to make it into the final schedule. So let's jump into our review cycle. And now, I mean, imagine I'm the lead planner again at this point in time, right? So I'm no longer the individual performing markup. I'm the person responsible for building the schedule. I've captured the feedback from my team. Now it's time to actually see what that's done to my plan. So immediately, the first thing we see when we begin our review process is that aggregated feedback. So this reflects the team's confidence or their uncertainty, yeah, in the plan durations for really every activity within the schedule. And we've got 9 activities so far that our team has provided feedback on. And we can also see the feedback this has. We can also see what the impact of this feedback is on the plan by looking at our change in baseline dates, our change in end dates. So, for example, as we walk through our design scope and we get to create early stage construction documents, we've actually, added 8 days in duration to this specific activity. But because of the knock-on effect associated with the other elements within the schedule, we've actually delayed this specific activity's finish by 18 days. So Keith, we talked about scenario modeling a little bit earlier and how we can kind of simplify the process of understanding the impact of risk on our plans. So let's take our established permitting documents one more time. Let's take this example and understand the impact of the feedback from the team and the risk events. So right now, Keith, you said it would take 50 days. Brian said it would take 50 days. I actually said, you know what? I think it's going to take 57 days. So our aggregated feedback suggests that this specific activity is going to take 52 days. This is the uncertainty associated with this specific plan. And at this point, I can go in and incorporate your feedback into the schedule. I can take the aggregate. I can say, you know what? Let's ignore Paul's feedback and take Keith and Brian's feedback. And incorporate it into the plan, but I can also take it a step further. I can say, not only that, we've identified 2 risk events associated with this. One we identified during the original planning process, and another I identified when I was performing my markup process. So if I want to see in real time and model a scenario where I can understand the expected impact of that risk, I simply turn those risks on for this activity, and I can see that I've added 60 days in duration to this specific activity because of the expected impact of those 2 risk events that we've identified. And not only that, I can see the expected impact on this activity, but I can see how it impacts the rest of my schedule as well. So we've also identified, if we go back up to our design scope, we've also identified a risk at the summary level. So we've got a risk of design delays due to poor scope definition. And that risk event, because it's defined at the summary level, gets kind of diluted across the elements that sit beneath it. So we can also turn on that risk event and see not only the impact of the discrete events tied to each one of the activities, but those summary level risk events as well, and how that spreads across the elements within our schedule. And then we can decide what actually needs to make it into the schedule itself. And do we want to embed those risks and the impact of those risks in our durations and not really treat them as risk events? So I'm going to jump back real quick. We're going to take a look at this establishing permitting documents element again. And right now we're getting an expected impact based upon these 2 risk events, their probability scores, and the impact for duration, right? But both of these risk events, we know are more often than not, risk events are binary, right? The risk event either occurs or it doesn't. So right now we're seeing an expected impact, which is great for macro level analysis. But if I wanted to say, you know what, show me at a P75 what the impact would be for these risk events. And now what's happened, instead of using that expected value score, we've actually said, you know what, both of these risks are going to fire kind of during that simulation process, and therefore the resultant impact is actually 120 days. So this starts to really provide a flexible means to model scenarios and really understand the impact of risk on our schedule, either down at a very discrete level like we're doing right now, or even at an overarching level for all the risk information that may have been incorporated into our project during this process. So real-time scenario analysis, not as a separate kind of risk exercise, and something that really does a better job at allowing us to make informed decisions. And then if we start to look at the analysis the AI engine is providing us, we can see now we're actually falling outside of our phases. We know that we've significantly extended the duration for our pre-construction activities and our design-related scope, right? So we're breaching our benchmarks from our knowledge library based upon the risk events that we've identified as part of this process and the feedback from the team as well. And the downstream impact, we're now starting our submittals and approvals for our procurement-related scope much later than we traditionally would have. So again, it allows me to take action and leverage the analysis to build a more realistic and feasible schedule. So really, Carolyn, this takes us kind of to the conclusion of our presentation today. But from what we built within Basis, previous risk modeling techniques have been so abstract in nature, and we can now, be driven by the feedback and confidence of the team. Like we can actually derive and drive our initial schedules by the confidence from the team. And instead of waiting on these traditional simulation modeling exercises, we get a real-time view of our risk-adjusted schedules, so we can actually make an informed decision on what makes it into the plan for execution. In the old world, we'd build a plan, we'd develop our forecast, and only then would we go back and consider things like schedule risk, and only then would we go back and think through things like team buy-in and confidence in the plan. Only then would we go back and look at, did I capture the right risk events or that could materially impact my plan. So with Basis, we don't have to do that any longer. We can get the plan right the first time and merge the process of risk analysis with how we actually build plans and understand risk before we embark on actually executing the project.
It's a more natural way to plan a project.
It is. It is.
And that's what actually makes it a better crystal ball.
It is. All right.
Well, you guys have done a very good job of filling our hour. I'd like to thank you both for your time, and it was really good also to see some of it working behind the scenes on the fly. So you guys did a good job of giving us some really tangible examples of how to work through those risk questions. We have another topic coming up next month. Join us again on July 24th, which happens to be a Wednesday. We'll be talking about machine learning and how machine learning is really changing the game for the planning profession. We're getting a lot into some of the technology topics here, but hopefully you've heard a lot today around incorporating risk and accounting for that in your plans. And next month, we'll be talking a little bit more about how you can make that technology work for you and how it really works on the back end. So join us again in July, and thank you all for your time today. Paul and Keith, you did a great job, and we'll talk again. Thank you, everyone.
Thank you all.